So today we're going to be doing lesson 7.4. We're going to be talking about the different numbers of solutions. There's infinitely many solutions, so that means any number could be a solution. There's no solution, and then there's one solution. And we've been dealing with one solution this whole time. We've been finding one solution to the answer, where now we can figure out that sometimes there's no solution, sometimes there's multiple. Okay? So let's start with our warm-up. We have the great Carlo called twins Jasmine and James onto the stage. Jasmine, so this is what he told her, Jasmine, multiply your age by 3 and add 6. Then multiply this sum by 2. James needs to multiply his age by 2 and add 4, and then multiply the sum by 3. He says he predicts that they will both get the same number. So we're going to write expressions for each person. So let's deal with Jasmine first. So when it says multiply your age, do we know her age? Do we know James's age? But what do we know about those two that will help us? They're twins, so their age is the same, right? So we know that they're the same. So we can use a variable to represent their age that will represent both of their ages because they're the same age, okay? So when it says multiply your age by 3, how do I show multiplying something that we don't know?
3x.
3x, good. We'll use the variable x for her age. 3x, because it's 3 times her age we don't know. Then we add 6. You guys know what adding is. We're going to add 6. Then it says multiply this sum by 2. How could I show taking 3x plus 6 and multiplying that by 2? Jaden? We could put it at the end. We could put it at the beginning. It doesn't matter. Either side works, right? Because order of operations, we have to do what's in parentheses first, right? All right, so let's deal with James. Who thinks they know what expression we would use to represent James's age? Go ahead, Gabriel. Gabriel, go ahead.
3 parentheses 2x plus 4.
Good, because it says 2 times, or multiply your age by 2, that's the 2x, add 4, and then multiply that sum by 3. Very good. All right, so we just wanted the expressions, but we're going to go a little farther with this, okay? Like I said, order of operations, I have to deal with what's in parentheses first, but can I combine 3x and 6?
No.
Why not?
Because one has a variable and one does not.
They're not like terms, right? I can't combine unlike terms. So what can I do to simplify that expression? Go ahead, Gabriel. Good, I'm going to distribute, or good, I'm going to multiply this 2 to both of these, and I'm going to do the same with James's. I'll multiply that 3 by all the terms inside the parentheses. So 2 times 3x is, you can just say it, 6x, and 2 times 6 is, okay, 3 times 2x, again, is 6x, and 3 times 4 is 12. So, if we look, we still have the same thing on each side. Looking from this, do we think that they're going to get the same answer? Yeah, they'll get the same answer, right? Because when we simplify this, we have the same expression on both sides. So, this answer would have any number we put in for our variable, we'll get the same number, right? No matter what their age is. Okay, so let's go ahead and move on. We'll talk more about what that means in a minute. This is the homework from Friday. I'm not going to go over it, but you can look on the slides afterwards just because we're running out of time, or I want to make sure I get through this lesson, so you can look at it later on if you are having trouble with that homework. Here is our lesson 7.4. Today's date is March 2nd, 2021. I can determine the number of solutions, and it should say an equation has. All right, let's start with example 1. For what values of x will the rectangle and triangle have the same perimeter? So first of all, how do I find perimeter of a shape?
Add the things on both sides of, well, all four sides.
I add all the sides together, right? Perimeter, I'm adding up all the sides. So in rectangle's case, I'd add 4 sides. Triangle, I'm going to add 3 sides, right? Because that's how many sides they have. Okay, so let's first look at this rectangle. I know what this side is. So then this side must be the same, right? So this must be x as well. If this side is 2x plus 3, then this side must be 2x plus 3. Right? Okay, so I'm going to make 2 different expressions to make one full equation. So if I have my rectangle, and I'm wanting to find the perimeter, I could do 2x plus 3, 2x plus 3, plus x plus x. Or, I know I have 2 of each of those, so I could do x plus x, that's 2x, right? And then I know I'm going to take 2x plus 3 and multiply it by 2, so I could do that. I'm fine if you do x plus 2x plus 3 plus 2x plus 3. But I'm just shortening it so it's a little less that we're writing, right? So let's look at the triangle. Who can give me an expression to represent the perimeter of the triangle? Go ahead. Brooke, go ahead, Brooke, sorry. Good. You could have also done 2x plus 2, plus 2x plus 2, plus 2x plus 2, but that's a lot more writing, right, when we know that we're going to multiply by 3 because there's those 3 sides. They're all the same. Good. All right. Jacob, did you have a question?
Yes, you do.
Okay, go ahead.
So, you just have added 2x plus 2x plus 2x.
Yeah, I mean, yes, you could have done that as well.
It just had like 6x plus 6x.
Which that's what we're going to have, right, when we distribute. I'm fine with that too. Yeah, yeah. Okay, so let's go ahead and simplify this first one. I have 2x. I need to distribute this 2. 2 plus 2, or 2 times 2x, sorry, is what? Good. And 2 times 3 is? 6. Good. And then like Jacob said, I'd have 6x plus 6, because 3 times 2x is 6x, 3 times 2 is 6, right? Now, what do I have to do to the rectangle side? What do we notice about that?
There are like
I have like terms. I can combine 2x and 4x to make
6 things.
Oops. Got to keep my color coordination. Okay, so we notice we have the same thing on both sides. I'm going to go even farther, okay? Let's solve it like we would a regular equation. I want to get all of my variables on one side. I want to get all of my constants on the other. Well, we notice that 6x and 6x are the same, so I wouldn't have to figure out which one's smaller. I'm just going to go ahead and get rid of this one. Subtract 6x. I'm going to do it to the other side. Well, 6x minus 6x is 0, right? So both of these will cancel to 0. And I'll be left with 6 equals 6. Is that correct?
Yes.
Yeah, we know that 6 is equal to 6. I could have figured out, without even moving those variables, that they're going to be the same on both sides. So, whenever it's the same on both sides, so I can't really solve this any farther. We know 6 equals 6. So that means that that has infinitely many solutions. If I put any number I put in for x would work in this equation, okay? I could put in 5 million for x, I get the same thing every time. Does that make sense? Because most of the time when we're solving equations, there's one number that I can put in for my variable that will be correct. In this case, any number I put in is going to have a correct equation. So, if I were answering this, so what values of x will the rectangle and triangle have the same perimeter? I would say because 6 is equal to 6 is always true. No matter, I mean, really, it's always going to be true. 6 is the same thing. All values of x will make the equation true. So, the equation has infinitely many solutions. And I'm not a huge fan of that term, but that is the term that they use every time that you see this. Any book, any curriculum that you'd use, they'd say infinitely many. And that just means any number. Infinite means like it goes on forever, right? So any number you put in there would be correct. Yes, Carson. We're going to skip this try it for now. Well, actually, let's just look at it. We're going to just look at it. If you look on this left side, it's that simplified. It is because there's no other like terms, right? Well, let's look on this right side. Are there any like terms?
Yes.
Yeah. Jaden, give me a set of like terms. 2x and x. Are there any other like terms? Good. 10 and 5 are also like terms. So if I were to combine 2x and x, I'd get 3x. If I combine 10 and 5, I get 15. So we can see already that we're going to have infinitely many solutions because the equation will be exactly the same on both sides, right? Okay. Let's move on to example 2. Anna and Lee played soccer for the same number of hours one week. So I know Anna, the number of hours that Anna plays soccer is going to be equal to the number that Lee plays. How many hours did Lee play on Sunday? All right, so let's look at their schedule. We've got on Sunday, Anna played, actually, Sunday, Monday, Tuesday, Friday. She played for X and then 1.2 hours. So I could show that as X plus 1.2. That's one day. But she did that for 4 days, right? It's the same for 4 days. So I'm going to multiply that by 4. Now Lee's is not as easy. We've got X hours, that's Sunday, 2.5 hours on Monday, 2X hours on Tuesday, and 4.5 hours on Friday. So I'm going to write all those out. What I'm going to have you do, take a minute. I want you to simplify each side of this equation. So simplify each expression in these equations. I'll give you a minute to do that. Side. Somebody that hasn't answered yet.
Simplifying the 4x plus
Well, so when I multiply 4 times x, it's 4x, but what's 4 times 1.2? Jacob?
Yeah, that's, is that what you're doing?
Yep.
Okay. So, uh, 4 multiplied by 1.2 is 4.8.
There you go. Good. All right, and that's simplified because 4x and 4.8 are not like terms. All right, somebody else that hasn't answered yet. What is Lee's side simplified to? Three x plus 7. Very good. Because x and 2x are like terms, 2.5 and 4.5 are like terms. So we combine those, we add those together. Very good. All right, so first of all, I see that these are not the same on both sides, right? So I'm going to continue to go. What would be my first step to solve this? And why did you choose 3x instead of 4x? Yeah, like I said, you could do either way. I always just like to get rid of the smaller one because it usually gives us a positive rather than a negative. So I'm going to subtract 3x from both sides. 3x minus 3x is 0. What is 4x minus 3x? X. Good. 1x or x. All right. What's my next step? Good. It's plus 4.8. The inverse operation is to subtract. I do that to both sides. 4.8 minus 4.8 is 0, so I'm left with x. What is 7 minus 4.8? 2.2? Okay. We see that x is equal to 2.2. This has one solution. Like I said, we've been finding one solution this whole unit. When you have x equals one number, that's a one solution answer. Okay? So this equation has one solution. Okay? Let's answer our question. How many hours did Lee play on Sunday?
2.2.
Yeah, because Sunday is X, right? So Lee played soccer for 2.2 hours on Sunday. So one solution, it should be easy because that's what we've been doing this whole time. Any questions? All right. Example 3. You're fine. All right, Gil makes 3 bracelets and Mika makes 2 bracelets. They both use the same number of string colors. How many colors should they use to make the same amount of money? All right, so we have Gil is going to be equal to Mika because it says they have the same number of string colors. All right, it says Gil's bracelets are $5 per bracelet plus $2 for each string color. All right. We also know that Gil makes 3 bracelets, right? So if he's making 3 bracelets, it's $5 per bracelet plus $2 for each string color. Well, we would do 5 because we know that. Do we know how many string colors he has? No, we don't know that. It says that they have the same number, but we don't know how much they have. So we're going to be adding, I'm not going to do S because my S's look like 5, so I'm going to do C. But we know that there's 3 of them, right? How would I set up Mika's if she has $3 per bracelet and $3 for each string color? She's making 2 bracelets. Somebody that hasn't answered yet, what would I use for that expression? How would I set up that expression? Good, we would have 2, because she's making 2 bracelets, and then in parentheses 3 plus C. Did I do that right? Oh, guys, I didn't include the price of the colors. So it should be 3C and 2C. Sorry. Today is my day of making mistakes, apparently, because should have been here third hour. All right. So we need to distribute 3 times 5 is 15, and 3 times 2C is
6C.
Okay. I'm going to do the same on Mika's side. I'm going to distribute this 2. Where did that come from? All right, 2 times 3 is,
6.
and 2 times 3C is.
6C.
All right. Next, I want to solve this equation. If we look, 6C and 6C are equal to one another. So I'm just going to subtract 6C, and those both cancel to 0, right? Is 15 equal to 6? No. There's nothing else I can do with this equation. We know that 15 is not equal to 6. That's not the same number. So in this case, because 15 does not equal 6, and that's how we show does not equal. We have an equal sign with a line through it, doesn't equal. There is no solution. So now we've done all 3. We had infinitely many solutions. That means that they're equal on both sides. We have 1 solution. That means we're able to solve the equation. Then we have no solution, which means they are not equal on both sides. I didn't even have to subtract the 6C to see that they're not going to be the same, because I have the same variable or same coefficient and variable. They're going to cancel each other out. I'm going to be left with those 2 constants that are not equal to one another, right? I could subtract the 6 from both sides, and then I'd be left with 11 equals 0, which is still not true, right? No matter what I do, I won't find a solution to this. So the question says, how many colors should they use to make the same amount of money? They'll never make the same amount of money because there's no solution. Okay? Is this ringing a bell from those videos that you watched yesterday on Khan Academy? Okay, it should. Good. All right, I'm going to have you do one on your own. How many solutions does the equation 4x plus 8 equals 0.1x plus 3 plus 3.9x have? And then you need to explain. Let's go over this. All right, so what do I need to do first? All right, so give me a set of like terms, Gabriel.
0.1 and 3.9.
X, right? Don't forget those x's. All right, so I'm going to rewrite this first expression. What is 0.1x plus 3.9x?
4x.
Okay. Do I need to go any farther to see how many solutions this has?
No.
I don't have to, because I see, one, that I'm going to be basically canceling out those 4x's, because that's the same. So if my coefficient and variable are the same on both sides, but my constants are different, how many solutions am I going to have? No solutions. So I could say no solution, and my explanation would be 8 is not equal to 3. Okay? So really the only one that you have to work out all the way is when we have one solution, because you have to find that one solution. But you should be able to get to this step and figure out if it's one solution, no solution, or infinitely many solutions. All right? All right. I'm going to do this last example because that's basically what we're doing is you work it out without solving the equation, so getting to where those are the same on each side. So your homework is 3-2-21 assignment, lesson 4-7. It's already on Google Classroom. Your Unit 7 test will be Monday and Tuesday of next week. All missing work from Unit 7 is due that Tuesday. All right? I'll answer those in just a second. All right, your exit ticket. Well, one variable equations always have one solution. So we kind of answered this. If you look at all of them, all of our examples, did they have a one variable equation? So you should be able to answer that. Once you're done with your exit ticket, you're free to go. Have a great day, and I will see you on Thursday.